Hi everyone, this is the Nordic Venture Show, your guide to the exciting world of Nordic startups and venture capital. In today's episode, we're exploring a startup called Bluefors.
Okay, so we've got a bunch of new stuff from Bluefors.
Yeah.
Blog posts, media announcements, all detailing their latest work in ultra low temperature tech.
Mhm.
And today, I think it'd be great to dive into all this new stuff and try to really understand how these advancements are pushing the boundaries in areas like quantum computing and all these other really exciting fields.
Yeah, absolutely. I mean, Bluefors has really become a key player globally when it comes to cryogenic measurement systems.
Right.
And of course, they're well known for their support of quantum technology. But their systems are also really essential for fundamental physics research.
Yeah.
And we're also seeing them more and more in life sciences and even clean energy.
Oh, yeah, for sure.
So, it's really interesting to see how these two brands, Bluefors and Cryomech, are kind of working together in this space.
Yeah, and what really sparked our interest was, their direct engagement with the challenges of scaling quantum computers.
Right.
Achieving and maintaining these incredibly stable, ultra-low temperatures that are
Yeah.
needed for quantum computing, and
Yeah.
then, trying to add more and more components, and
Yeah.
it just seems like there are some serious engineering hurdles that
Oh, yeah,
that need to be overcome.
for sure.
And that's what we're going to dig into today, is how Bluefors is tackling these challenges head on
Hmm.
with significant improvements in cooling power and some pretty innovative wiring solutions.
Yeah.
So so let's start with this enhanced cooling power
Okay.
that we've seen highlighted in a lot of their materials.
Yeah, let's unpack this a bit.
Okay.
So as researchers are aiming to build quantum computers with, more and more qubits, those fundamental building blocks of quantum information,
Mm-hmm.
they need more connections, more lines of communication to
Yeah.
control and read out those qubits.
Yeah.
And so all of this additional wiring, along with any active electronics that are
Yeah.
designed to operate at these super cool temperatures,
Mhm.
all of that generates heat.
Got to go somewhere.
Yeah. And so
Yeah.
this heat buildup,
Mhm.
really becomes a major roadblock.
Yeah.
Particularly at what's known as the 4 Kelvin flange of the dilution refrigerators.
Okay.
These are essentially the workhorses for achieving these ultra-low temperatures.
Yeah.
And, even in the material you shared, it referenced some work by Raiku et al.
Right.
From 2025,
Mhm.
really underscoring this exact challenge.
Yeah, it's kind of like trying to cool a server room.
Right.
The more servers you pack in,
Yeah.
the harder that cooling system has to work.
Exactly.
So what's Bluefor's strategy for dealing with this, ever-increasing heat load?
Well, what's really fascinating here is their approach.
Okay.
They have this, deeply optimized way of integrating cryogenic pulse tube cryocoolers
Mm-hmm.
directly into their dilution refrigerators.
Okay.
And it's not just about, bolting on a more powerful cooler.
Right.
It's a true collaboration between their R&D teams
Oh, wow.
in Helsinki and Syracuse.
Yeah.
They're blending their expertise in both dilution refrigeration and the technology behind these cryocoolers.
Yeah.
And so this synergy has really resulted in a significant surge in cooling power,
Okay.
precisely where it's most critical, at that 4K flange.
Wow, that sounds like a real leap forward.
Yeah.
So can you give us a sense of just how much more cooling power we're talking about?
Sure.
What were some of the previous limitations that this increase is helping to overcome?
Yeah, so when these enhanced systems are running at around 3 Kelvin,
Okay.
the cooling power at that 4K flange actually doubles.
Wow.
So to give you a concrete example,
Yeah.
the LD400 system,
Okay.
now equipped with the enhanced PT310-RM pulse tube, can achieve 500 milliwatts of cooling power
Okay.
at 3K.
Got it.
Previously, you might have seen systems in this class offering around half that.
Yeah.
So this jump isn't just a number.
Yeah.
It potentially allows researchers to maintain that delicate coherence of quantum states.
Yeah.
In systems with a significantly larger number of qubits,
Right.
which was previously much harder to achieve due to the increased thermal noise from all the extra components.
Yeah, that makes sense.
And then for the larger XLD-1000 Zello system,
Okay.
using a combination of PT425RM and PT310RM pulse tubes,
Mm-hmm.
that cooling power jumps to a substantial 700 milliwatts
Wow.
at the same 3K operating temperature.
Okay, so that's a huge difference.
Yeah.
But, the sources also mention this ability to operate at slightly warmer 4K flange temperatures.
Right.
Why would you want to do that?
Yeah, this is where it gets really interesting.
Okay.
So the improved integration allows that 4K flange to operate at slightly higher temperatures,
Okay.
up to around 5 Kelvin,
Mm-hmm.
without compromising the even colder temperatures reached in the dilution stage where the quibs reside.
So it's kind of like giving the first stage of cooling a bit more breathing room.
Exactly.
Okay.
And by allowing this slightly warmer operation at that 4K flange, the available cooling power actually triples.
What?
Yeah, so take the LD400 again.
Okay.
With the enhanced PT425RM at 5K,
Okay.
it can now provide a remarkable 1,500 milliwatts.
That's a lot.
It is.
Okay.
And the XLD1000 Zelado with a dual PT425RM configuration
Mm-hmm.
can deliver between 1,300 and 2,000 milliwatts
Wow.
at around 5K.
Okay.
So that's a massive increase.
It is.
And it opens up possibilities for running experiments with significantly higher heat loads,
Right.
something that would have been a major bottleneck before.
So if you're listening to this and you're facing limitations in your cryogenic setups
Yeah.
due to cooling capacity, just imagine having a cooling system that can suddenly handle double or even triple the heat.
Yeah.
So what kind of Bluefors systems can actually take advantage of this enhanced cooling capability?
So the enhanced 4K cooling is currently available for a range of their widely used systems,
Okay.
including the LD400,
Mm-hmm.
and that includes the ultra-compact LB and even the side-loading versions, which we'll get to shortly.
Okay.
It's also available for the XLD1000 Sensel system.
Gotcha.
And in terms of the specific pulse tube models
Yeah.
that incorporate this enhancement, you have options with the PT415RM, the PT425RM, and the PT310RM models.
Okay.
So there's quite a bit of flexibility
Yeah.
depending on your specific system and needs.
And it sounds like this improvement is designed to be, relatively straightforward for those already using these systems.
Exactly.
Yep.
The enhanced integration uses the same physical space and positioning within the cryostat.
Mm-hmm.
And this is a huge advantage because it means that researchers don't have to completely re-engineer
Right.
their experimental setups just to take advantage of this increased cooling power.
So it's essentially a more powerful cooling engine within the same chassis.
Exactly.
Got it.
Minimizing disruption to existing research.
Yeah, that's a significant benefit in terms of minimizing downtime and redesign.
Right.
And it sounds like the advantages extend beyond just increased cooling capacity.
That's right. So the optimized pulse tube integration also results in better low vibration performance,
Okay.
which is absolutely critical for those delicate quantum experiments where even the slightest vibrations can disrupt qubit coherence.
Right.
Plus, it even contributes to a decrease in the overall cool-down time of the systems,
Oh, wow.
allowing researchers to reach those ultra-low operating temperatures faster
Yeah.
and start their experiments sooner.
Okay, so let's connect the dots here a little bit.
Okay.
Why is this enhanced cooling power so crucial for the advancement of quantum technology and other fields operating at these temperatures?
Well, if we connect this to the bigger picture,
Yeah.
this increased cooling power directly addresses a fundamental limitation in scaling up quantum computers.
Okay.
It provides the thermal headroom
Mm-hmm.
needed to integrate the increasingly complex wiring
Yeah.
required to control and manipulate larger numbers of qubits.
Right.
It also makes it feasible to incorporate more active cryogenic electronics like cryo-CMOS and low-noise amplifiers,
Yeah.
which are essential for performing more sophisticated operations on these quantum systems.
Mm-hmm.
Furthermore, it opens the door to accommodating larger experimental setups
Okay.
and even achieving even colder temperatures,
Yeah.
sometimes needed for advanced superconducting magnets
Right.
used in various areas of research.
Yeah.
So essentially, it removes a significant bottleneck in the pursuit of more powerful and intricate cryogenic systems.
Okay. So more qubits, more sophisticated control, more ambitious experiments,
Right.
all enabled by better cooling.
Exactly.
Now, alongside this boost in cooling, Bluefors has also introduced a novel approach to managing the increasing density of wiring.
Yes.
This high-density flex wiring, or FPC.
Right.
Tell us about that innovation.
So this is another really exciting development.
Okay.
And, it's focused on tackling that challenge of routing a massive number of signal lines within the constrained space of a cryogenic system.
Right.
And so the high-density flex wiring, or FTC,
Okay.
is a new, cost-effective platform based on flexible printed circuit technology,
Okay.
specifically engineered for their cryostats that feature side-loading ports.
Side-loading ports, just to make sure we're all on the same page here.
Yeah.
Those are those ports on the sides of the cryostat that offer a more accessible way to insert and remove components and wiring, right?
Precisely.
Okay.
And this FTC technology allows for a remarkable increase in wiring capacity,
Okay.
offering the potential for up to 240 individual channels
Wow.
per side-loading port.
Okay.
That's a significant density of signal lines packed into a relatively compact area.
Yeah, that's a staggering number of wires.
It is.
So how do they manage to fit so many in there
Right.
without adding, even more to the thermal load that we were just discussing?
Well, what's particularly clever here
Okay.
is that these FTC lines are described as lossy lines.
Okay.
Now, while lossy might typically sound like a negative attribute
Yeah.
in signal transmission,
You don't want to lose your signal?
right, in this very specific cryogenic context, it's actually a benefit.
Oh, okay.
It means that these lines are designed to dissipate some of the high-frequency energy as heat along their length.
Right.
And the key is that by distributing this heat over a larger surface area,
Yeah.
it actually leads to a lower overall thermal load at the coldest stages of the dilution refrigerator,
Okay.
compared to using traditional low-loss coaxial cables when dealing with such a high density of lines.
I see.
So it's a carefully engineered trade-off
Yeah.
that ultimately enhances the overall performance of the system
Got it.
by preventing those localized hotspots at the most sensitive areas.
So these FPC lines are specifically optimized for handling high-frequency signals then?
Exactly.
Okay.
The FPC wiring has a frequency range that extends up to 12 gigahertz,
Mm-hmm.
making it perfectly suited for those drive lines necessary to control a large number of qubits in both superconducting and spin qubit-based quantum computing platforms.
Okay.
So it's designed to reliably transmit those complex high-speed signals required for advanced quantum control.
And what about the physical form factor?
Mhm.
How does this FPC wiring integrate into the existing cryogenic systems?
So it's designed with a continuous form factor,
Okay.
meaning a single FPC assembly runs seamlessly from room temperature all the way down to the mixing chamber flange,
Mm-hmm.
the coldest point in the dilution refrigerator.
Got it.
And this eliminates the need for numerous connectors at different temperature stages,
Right.
which can often be sources of both thermal leaks and signal degradation.
Yeah, that makes sense.
Yeah.
And in terms of compatibility, it's designed to work with Bluefors' current range of side-loading systems.
Yes, it's specifically engineered to integrate directly into the side-loading ports of both their XLD and LD series cryostats.
Okay.
The installation process also appears to be quite streamlined.
Okay.
The FPC assemblies can be pre-configured and assembled
Mm-hmm.
before being inserted into the ports. Each port can accommodate anywhere from 1 to 8 individual FPCs,
Wow.
providing a significant degree of flexibility
Right.
to match various experimental requirements.
Yeah.
Furthermore, Bluefors offers a range of compatible components, including attenuators and filters,
Mm-hmm.
which can be integrated directly into the FTC assemblies.
Got it.
The entire package comes complete with all the necessary connectors.
Okay.
SMPM connectors at the ultra-cold mixing chamber flange,
Mm-hmm.
and standard SMA connectors at the room temperature end.
So if you're grappling with the increasing complexity of wiring
Yeah.
for your quantum experiments, this FPC technology sounds like it could really simplify things and provide a more scalable pathway for future advancements.
Absolutely. It directly addresses that growing demand for higher wiring densities as qubit counts continue to climb.
Right.
And the modular design suggests future potential for even greater densities, lower signal losses, and more integrated options for signal conditioning within these high channel count systems.
Yeah, very cool. Now, these advancements in both cooling and wiring seem to have paved the way for a brand new system from Bluefors,
Yes.
the LD400 system.
Right.
What's the key innovation with this new system?
So the LD400 SL is essentially a new variant
Okay.
of their already well-established LD400 dilution refrigerator system,
Mm-hmm.
but with a significant and very practical addition.
Okay.
It now incorporates 2 side-loading ports.
Okay.
This brings the added convenience and flexibility of side-loading,
Mm-hmm.
which was previously more commonly found on their larger XLD series systems,
Right.
to the more compact and versatile LD platform.
So it offers that easier access for installing and reconfiguring measurement infrastructure modules.
Exactly.
Similar to what we've seen with their larger systems.
Precisely.
Oh, cool.
And crucially, the LD400 also maintains the same core performance specifications
Okay.
that have made the standard LD400 so popular,
Mm-hmm.
but the integration of those 2 side-loading ports,
Yeah.
which naturally allows for more complex internal setups. With increased wiring and cryogenic components
Yeah.
is where that enhanced 4K cooling we discussed earlier becomes particularly vital.
Okay.
It provides the necessary thermal management to effectively handle the potentially higher heat load associated with this expanded experimental infrastructure enabled by the side-loading design.
So it's a really synergistic effect.
It is.
The improved cooling power makes it possible to utilize the greater flexibility offered by the side-loading ports, which in turn can take advantage of the high-density wiring solutions we just talked about.
Precisely.
Cool.
The LD400 SOLA is specifically designed to fully support both the new high-density flex wiring, or FPC, and their existing range of high-density wiring options
Okay.
through those integrated side-loading ports.
Yeah.
This makes it an exceptionally well-suited platform for tackling complex experiments,
Okay.
particularly in quantum computing applications that demand a large number of qubits within a cryostat
Right.
that still maintains a relatively compact footprint.
And for research labs that might operate both LD and XLD systems,
Right.
there's a clear advantage in terms of compatibility of peripherals and measurement tools, right?
Yes, this is a significant practical benefit.
Mm-hmm.
All of Bluefors' existing side-loading measurement infrastructure options are fully compatible with their XLD systems. This means that the new LD400 LE can serve as a highly versatile platform for both developing and testing complex quantum experiments,
Okay.
allowing researchers to seamlessly transition and scale up their setups to the larger XLD systems without the need to completely redesign their wiring and measurement configurations.
That could save a lot of time
Yes.
and resources in the lab. That
Exactly.
sounds like it could really streamline the research workflow.
Yeah.
And the side-loading feature itself must offer some tangible benefits for the day-to-day operation and maintenance of these, sophisticated systems.
Absolutely.
Okay.
The side-loading design significantly simplifies the assembly and ongoing maintenance of complex wiring and component infrastructures. Researchers have the flexibility to prepare and pre-assemble intricate wiring modules on a separate workbench,
Right.
while the cryostat is still running.
Yeah.
Then, when the system is brought back to room temperature, these modules can be quickly and easily inserted or exchanged via the side ports.
Okay.
This dramatically improves efficiency
Yeah.
and helps to minimize valuable experimental downtime.
That's great. So for anyone listening who might be considering incorporating one of these new systems into their lab,
Right.
what's the current availability?
Well, the good news is
Okay.
that the LD400 Solio system is available for order and delivery immediately.
That's fantastic.
And for those who require an even more compact solution, the side-loading configuration is also now available as an option for their ultra-compact LD system.
Very cool. So Bluefors' focus isn't solely on these specific hardware innovations, though.
Right.
It seems that they have a broader commitment to supporting their customer base.
Yeah, that's a fundamental aspect of their approach.
Yeah.
They place a strong emphasis on ensuring that their systems deliver maximum uptime and optimal performance throughout their operational lifespan. And this is reflected in their comprehensive range of services and ongoing technical support.
Yeah.
They're really looking at the entire life cycle of their products, not just the initial sale.
And they are actively involved in quite a diverse range of scientific and technological domains beyond just quantum computing, right?
Yes, while quantum technology is certainly a major area of focus
Yeah.
and a significant driver of their innovation,
Right.
Bluefors also provides critical cryogenic solutions for fundamental physics research across many disciplines, as well as an expanding range of applications in medical and life sciences,
Okay.
and even the burgeoning field of clean energy technologies.
Wow.
So, their expertise in achieving and maintaining ultra-low temperatures is enabling advancements in a surprisingly broad spectrum of scientific inquiry.
Yeah, absolutely. We also noticed a flurry of recent news and updates from them.
Oh.
Were there any other particularly noteworthy announcements in there that our listeners should be aware of?
There were a few other interesting developments.
Okay.
For example, under their Cryomic brand, they recently launched a new compact 2 Kelvin cryocooler,
Okay.
the PT205.
Mm-hmm.
They also announced a collaboration with Qblocks,
Okay.
a company specializing in quantum control electronics,
Got it.
with the shared goal of accelerating the development and integration of combined quantum technologies.
Very cool.
Additionally, they've released a significant upgrade to their gas handling system, now in its second generation.
Okay.
And there was also news about the expansion of their Bluefors lab facilities to Chicago,
Wow.
indicating their continued global growth and commitment to providing local support and expertise to their customers in North America.
It definitely sounds like a company that is, actively pushing the boundaries and making significant investments
Yeah.
in the future of these critical technologies.
Right.
They even touched upon, broader considerations like sustainability
Yep.
in some of their communications.
Yes, it's encouraging to see that Bluefors is also paying attention to their broader impact beyond just technological advancements.
Yeah.
They've mentioned their commitment to principles of sustainability and social responsibility, which is an increasingly important consideration for companies across all sectors.
Yeah, for sure.
They also highlighted their participation in the upcoming Quantum Australia conference in 2025,
Okay.
demonstrating their active engagement with the global quantum research community.
So to bring it all together, it's clear that Bluefors is making substantial progress
Yeah.
in the field of ultra-low temperature technology. Could you give us a concise summary of the key takeaways from our deep dive today?
Absolutely. So we've explored how Bluefors is addressing those critical challenges
Yeah.
in scaling up quantum computing
Right.
and enabling other demanding applications through three primary innovations.
Yeah, okay.
First, a significant enhancement in the cooling power of their dilution refrigerators.
Right.
Second, a novel high-density flex wiring platform for achieving increased and more efficient signal routing within cryogenic systems.
Okay.
And third, the introduction of the new LD400 electrical system, which effectively combines the established performance of their LD series with the enhanced versatility of side-loading ports.
Got it.
Collectively, these advancements aim to significantly improve the cooling capacity, wiring density, operational flexibility, and overall scalability of their state-of-the-art cryogenic systems.
And it's evident that they're not innovating in isolation.
Right.
The ongoing partnership with Cryomec, for instance, really underscores the value of combining specialized expertise to drive these technological leaps.
Exactly, by strategically integrating their respective strengths. Bluefors and Cryomec are able to deliver more advanced and more tightly integrated solutions to meet the evolving needs of their customers in the scientific and technological communities.
So if you're thinking about the future of quantum computing
Yeah.
or any field that relies on the extreme cold,
Right.
consider this
What?
with these notable enhancements in ultra-low temperature technology. What entirely new scientific and technological breakthroughs might now be within our grasp?
Right.
What kind of ambitious experiments that were previously constrained by limitations in cooling capacity
Yeah.
or wiring complexity are now potentially within the realm of possibility?
It's exciting to think about.
It is. It's a very exciting period for innovation in these cutting-edge areas of research.
Absolutely.
Well, this has been a fantastic overview of Bluefors and all their latest advancements.
Yeah.
If you'd like to explore any of these new products and technologies in greater detail, we encourage you to visit bluefors.com.
Yeah.
You'll find comprehensive information, and you can easily connect with their knowledgeable sales engineers to discuss your specific requirements and applications.
Exactly.
Awesome. Well, thanks for joining us today.
Yeah, thanks for having me.
And we'll catch you next time on the Deep Dive.
How's it? Good.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.